This is our continuation of limits and continuity, and we are going to work with vertical asymptotes. So if direct substitution of a finite limit yields a non-zero value divided by 0, 4 over 0, negative 3 over 0, for example, then the x value in question is a vertical asymptote. Without question, then the left and the right-hand limits will approach infinity or negative infinity. Our task is going to be to determine which of these is appropriate. So we're going to determine the sign, whether positive or negative, of both the numerator and denominator as we approach from the left and right or both sides. So remember, just because the limit equals infinity does not mean the limit exists. It tells you that the limit fails to exist by denoting that it has unbounded behavior. So let's look at example 1. If an infinite limit increases or decreases without bound at a vertical asymptote. So our limit as x approaches 0 from the left is positive infinity. Our limit as x approaches 0 from the right is also positive infinity. And then we're going to state that our limit as x approaches 0 does not exist. As we see in example 2, to numerically approach vertical asymptotes, we need to substitute a decimal number approaching that limit. So we know that if we substitute in 0, we are going to get that it is undefined. Working from the outside in, if we substitute in 1/10, we're going to get 100. If we substitute in negative 1/10, we're also going to get 100. If we substitute in 1 over 100, we're going to get 10,000. And if we substitute in negative 1 over 100, we're going to get also 10,000. If we substitute in 1,000th, we're going to see that we're going to have 1 million, and likewise the same for negative 1 over 1,000th. So we would then say that the limit as x approaches 0 of 1 over x squared, 0 from the right, is positive infinity. Our limit as x approaches 0 from the left of 1 over x squared is also positive infinity. And then our limit as x approaches 0 of 1 over x squared does not exist. Okay, so beginning with example 3, first of all, I apologize. There's supposed to be some limit notation in here that somehow didn't stay. So this is the limit as x approaches negative 2 from the left of x squared plus 2x minus 8 over x squared minus 4. Now the first thing I'm going to notice is that I can simplify and factor my numerator and my denominator. So this is the limit as x approaches negative 2 from the left of x plus 4 times x minus 2 over x plus 2 times x minus 2. And so we can see that there's a hole at x equals 2. But we're going to go ahead and, so we have the limit as x approaches negative 2 from the left of x plus 4 over x plus 2. And now when we plug in values of x close to negative 2, but less than that because we are coming in from the left side, so that would be things like negative 3, negative 2.9, negative 2.1, we can see that we're going to end up with a positive value in the numerator, but a negative value in the denominator. And so then this limit goes to negative infinity. Now looking at b, we have, this should be the limit as x approaches negative 2 from the right of x squared plus 2x minus 8 over x squared minus 4. Jumping ahead to how I had it factored, this is the limit as x approaches negative 2 from the right of x plus 4 over x plus 2. And so this is plugging in values like negative 1.9, negative 1.8. And I can see that again, I'm going to have a positive value in the numerator and I'm going to have a positive value in the denominator. And so this limit goes to positive infinity. So for this next one, we're going to do both the limit as x approaches 1 from the right of 1 over x minus 1 squared, and as we approach 1 from the right, so 2 and closer to 1, we can see that obviously we have a positive in the numerator and a positive in the denominator, and so that's going to be positive infinity. And our limit as x approaches 1 from the left of 1 over x minus 2 is also going to then, sorry, that should be an x minus 1. Minus 1 quantity squared is again going to be a positive number over a positive number because we're squaring it, and that's also infinity. Now with this, and similar to example 2, we can also say the limit as x approaches 0 of 1 over x squared is positive infinity. So we can say that that is positive infinity. We can use d and e or positive infinity in the case of limits that are going towards infinity. You will never have to have both of those as an option on a multiple choice problem. Either will be accepted on a free response or short answer question. All right, so going on to, if I can get to the next page, there we go. Looking at example 4. So note that as we are looking at these, a vertical asymptote means that the function is not continuous. Vertical asymptotes occur where the denominator equals 0 and there is not a common factor, and the numerator is not equal to 0. So let's look at a couple of these. So as we're approaching 5 from the right, we are coming in from values greater than 5, and so we have positive value over positive, and so the limit as x approaches 5 from the right of x plus 2 over x minus 5 is going to be positive infinity. Our limit as x approaches 2 of 4, so we'll start with 2 from the right, x minus 2 quantity squared. It's going to be positive, and because this is squared, it's going to be positive. And the limit as x approaches 2 from the left, 4 over x minus 2 squared, positive in the numerator, positive in the denominator. And so this limit is going to be infinity. And again, you can also use does not exist. So similar to what we did on the previous page, we have the limit as x approaches 6 from the right. We need to go ahead and factor. So we have, this is going to be x, and the signs are different. This should be a positive, this should be a negative. This is going to be x plus 6 over x minus 6. So the limit as x approaches 6 from the right of x minus 2 over x minus 6. And again, we're coming in from values of x greater than 6. So we have a positive over a positive, and this is then also infinity. All right, so looking at D, we have the limit as x is approaching -1 from the right, so values greater than -1. We know that this is a negative in the numerator, and we're plugging in -0.9, -0.8. So this is going to be a positive number. And so then I can see that this limit, the limit as x approaches -1 from the right of -1 over x plus 1 is negative infinity. All right, so looking at E, we have the limit as x approaches 2 from the right. I'm going to go ahead and factor my numerator. So this becomes x. Actually, I am not going to factor my numerator. My numerator does not factor. So we're going to just simply evaluate this. So if we are plugging in values of x greater than 2, I can see that this is going to be a positive number. This is also going to be a positive number. And so the limit as x approaches 2 from the right of x squared plus 4x plus 6 over x minus 2 is positive infinity. Now, you've noticed that in example C and in a few of them on the previous page, I did factor. It is not necessary to factor it every single time. So let's look at example F. I'm coming in from values of x less than -7, so I can see that it's going to be a 0 over 0, or it's going to be a number over 0. So let's evaluate. We're coming in, so it's less than 7, so I can see that the denominator is going to be negative. And if I come in from the top, it's going to be, if I come in, so positive, this is also going to be, this is going to end up being positive, and so that limit as x approaches -7 of x squared minus 4x minus 21 over x plus 7 is negative infinity.